Hello everyone, exercise 11 we're going to take a look at, which covers interpolation and extrapolation, right? 11a. See the table below, okay, so we have the year 2000, 2007, 2016, and here we have fizzy drinks, mineral and spring water and juice and nectar. Use interpolation to estimate the consumption of fizzy drinks in 2010. Okay. Interpolation. Why interpolation? Because 2010 is between 2007 and 2016. If it's in between, it's called interpolation. Fizzy drinks. That means we have to take a look at this thing and at this thing, right? If you're going to take a look at those two data points, you see that there is a certain gap between them, right? Here, 96.7 minus 19.1 means there is 6.6 liters per person per year less. You can just say 6.6 less for here. But for how many? Well, how many years is it between 2016 and 2007? That's 9 years. So 6.6 less in 9 years. But I'm not interested in what happens per 9 years. I want to know what happens per year. So that means per year you will have 6.6 over 9 less. Oh, that's a weird way to write less. You can calculate this, but I would actually keep it in fractional notation. Then you know that you're not rounding too quickly. This is an exact value, so I would just keep it in fractional notation. Okay, we want to know 2010. 2010 is 3 years from 2007. So, in 2010, you will have your starting point, 96.7. And we have an reduction here, right? So we have less, so minus what? If it was just 1 year, I would have 6.6 over 9, right? Because 1 year, then I have this. But I don't have 1 year. I go from 2007 to 2010, so that's this minus this minus this. That's the same as saying, well, minus 3 times what I have less per year. And the deal will give you a total of 94.5 liters. Or what you can do is just do L, right? And this is interpolation because it's in between data points. At B, they want us to use extrapolation for what? Well, extrapolation for mineral and spring water. So this one. And most people take this one correctly, but I see some people then using this one to extrapolate with. And that's wrong. The agreement we made is that we use the two latest data points in this set. So we use 2007 and 2016. And it can actually change your answer quite a lot. So now to take the last two data points when extrapolating. Okay. Here, if I take a look, first, what happens in 9 years? Well, I have an increase this time of 3.8 more per 9 years. So, you can say 3.8 over 9. Yeah, I can do that, but I'm not taking a look at the data. Well, let's do it the way I normally would, right? Normally I would say, well, that means 3.8 over 9 per year more. And you will see that you don't have to do that for this exercise, actually. Why not? Well, because we're going to take a look at what happens in 2025. And in 2025, we take the data from 2016. And now you see something fun happening, because this is per year. And again, we are 9 years in the future. We go to 2025, that's 9 years more. And we already had exactly what I had for 9 years more. So I could just do plus 3.8 here, and then I have the answer. Or if you so prefer, let's say you didn't see that, just as I didn't see that at start. This is per year, but I have 9 years into the future. Yeah, and if you calculate that, 9 times this divided by 9, 9 times and divided by 9 cancel each other out, so it's the same as just adding 3.8. So that gives me 29.5 liters in 2025. Okay? It's still good to know how the method works, because oftentimes you don't have exactly the same time span that you used for the calculation that you go into the future as well. Let's see. Let's do the exercise here in that case. For C. Use extrapolation to estimate the consumption of juice and nectar in 2100. Okay. Comment on your estimates. Okay. Let's take a look. Extrapolation. So the last two of juice and nectar. So those two. By now you should know how to do this. So we take a look. We subtract them. In this case I have a decrease. So I have 3.4 less in 9 years. So in 1 year I have 3.4 over 9 less. Okay. So in 2100 I will have my starting value, which is 24.1 in 2016, minus, because we have a decrease, how many years are there between 2016 and 2100? That are 84 years times 3.4 over 9. And that will give me approximately minus 7.6 liters. Oops, that seems a bit weird. And normally you would then say, well, I've made a mistake in my calculation, but that's not what you're going to write down here. They want you to comment on this, and this is actually an example where extrapolating so far into the future doesn't give me an answer that is representable for the data. So comment on your estimate. You can comment on your estimate. You would say this is impossible. Extrapolating how do you write this here? Extrapolating is not a good tool for estimating the value so far in the let's go one more down, future. Again, if you have watched my explanation of the theory, not everything can be extrapolated, because not everything that we extrapolate on is a straight line. And if you go to extrapolate, you're going to assume this line is going down with the same rate for every year, and that's not the case. Normally a line that's decreasing will, at one time or another, is going to slow down. You will get something like this maybe, right? Or maybe in reality it goes down and goes actually up again, and you get something like this. So here extrapolating is not the way to find the correct answer, because you cannot find a negative value for the amount of liters that a person consumes per year. Okay, good luck.